Hi, in this video we're going to talk about gluconeogenesis and the 4 bypass steps that are involved, okay? Now, we are here with pyruvate inside the mitochondria of the cell. Now, the two biggest things that we need to accomplish with gluconeogenesis is to bypass those 3 regulatory or irreversible steps from glycolysis, okay? So that includes the glucose to glucose 6 phosphate via hexokinase. That includes the fructose 6 phosphate into fructose 1,6 bisphosphate via PFK. And that includes the pyruvate kinase turning PEP into pyruvate. Now that's the first big hurdle, getting over those 3 irreversible reactions. The second one is going to be trying to get the pyruvate out of the mitochondria back into the cytosol, because that's where gluconeogenesis takes place, mainly inside the mitochondria. However, there isn't a transport out of the mitochondria for pyruvate to take. So in order to do so, we are actually going to carboxylate our pyruvate using pyruvate carboxylase. We're going to add a CO2 using ATP, and we're going to turn it into oxaloacetate. Alright. Now, that's one of the big reasons why from oxaloacetate they're going to take 3 different steps to get out of the mitochondria, but we'll cover that in another video. We'll just assume that oxaloacetate is currently outside of the mitochondria and in the cytosol. At this point, the oxaloacetate is going to be decarboxylated. So it's kind of a, it's almost counterintuitive if you think about it. Why would we go from a 3-carbon molecule to a 4-carbon back to a 3-carbon? And that's to just get not only to bypass the regulatory step of get rid of the regulatory step of PEP into pyruvate, but also to get out of the mitochondria. So now that oxaloacetate is out of the mitochondria, it's going to turn into PEP using a phosphenylpyruvate carboxykinase. Try saying that 5 times fast. PEPCK or PEPCK, your choice. Instead of ATP as an energy source, it's going to use GTP. Okay, so this is something new. It's very similar to ATP, but instead of an adenine, it's a guanine. Alright, so PEPCK is going to take out a carbon in the form of CO2 and add that and add a phosphate to it. So we're going to have PEP. So those are the first 2 bypass steps to get pyruvate into PEP and to get that pyruvate out of the mitochondria. So the next 2 are fairly straightforward with the bypass steps. We're going to have fructose 1,6 phosphate bisphosphate turning into fructose 6 phosphate using fructose 1,6 bisphosphatase. Alright. It's going to have water come in, it's going to take out the phosphate group. Alright, and then after that, we're going to kind of have the same thing over again to get past hexokinase, where we're going to have glucose 6 phosphate turn into glucose via glucose 6 phosphatase. And kind of the same thing, water is going to come in, and a phosphate group is going to come out. Alright. So this is the gist of gluconeogenesis. In the next video, we'll talk more specifically about how that oxaloacetate came out of the mitochondria and into the cytosol. Alright.